All right, so let's take a look at the third page of our review. It actually looks like a lot of problems, but a few of them are really just piggyback problems off of one question. It kind of models how the test is laid out, where there's a bunch of true and false questions that are very, very small questions. So it may sound like a lot of questions, but it's really very quick. Anyway, off we go. So let's get into the idea of proving things are congruent. So we have this story in number 9 that says we are given that PS over here is congruent to Q. Excuse me. It says PS and QT bisect each other. Aha. Been a minute since I've read this question. Now that's actually really, really important. Because if they bisect each other, the definition of bisect means PS and QT cut each other perfectly in half. So I would know by the definition of bisect that QR is congruent to TR, and in turn, PR is congruent to SR. Now be very, very careful on the test because sometimes we would use that idea of bisect each other, and other times we might be a little bit different and just say one of them bisected the other. So keep in mind, just because one of them got bisected doesn't mean that they both did. In this case, they both did, so that's okay. Now we can go a little bit further, and remember, anytime you see those shared sides or those crosses, we get some nice automatics. So we want to remember that these two angles right here are congruent. So again, depending on how you like to write that, I think I'm going to write it as angle QRP. That's this angle right here. QRP is the same as TRS. That's by the vertical angle theorem. And the nice thing about that is that lays us out into a very nice pattern of a side angle side congruence. Notice I got two sides marked and an included angle, that angle that's literally right between those two things, which is perfect. And since I took the time to trace this carefully, QRP above, then not only is angle QRP, so is triangle QRP congruent to triangle TRS. So sometimes if you invest a little bit of time and instead of using 1 and 2, I actually saved myself a little bit. And then the last thing is, why is angle PQR, which is this angle up here, why do I know that this angle right up here with vertex Q, why do I know that that angle is the same as STR, which is this guy down here, is because if you follow the logic, angle T and angle Q are corresponding. So that is the whole thing where we use CPCFC. Now, this is corresponding parts of congruent figures, and these are congruent figures. So the corresponding parts of those congruent figures are, in fact, congruent. Now, keep in mind, since it's a triangle, some people would use this instead. They would use CPCTC because it is specifically a triangle as opposed to a generalized figure. Okay, moving on to problems 18. Actually, this is funny. It's like I need to change this. It's problems 13 through 17, it looks like. It actually could be even a little different because we're still in the process of modifying this review a little bit, but we're just going to find out which one of these were done correctly. So this is very similar to the problem above because this is not a proof, but we're just going to go ahead and put in information we know and just go for it. I know these two things are congruent by side angle side. So that means I know that not only are the triangles congruent, and so are the parts. So I can actually use that. So if I look at BAC, that goes across the unmarked and then the single. So that should be EDC, which is how this was stated. So that was well done. Then we could say triangle ABC, which would be a vertex angle B here, is the same as DEC. That was also, again, well done. Again, notice that angle B would be the same as angle E. The vertex is always the one that's sitting here in the middle when you use 3 letters. Now we said BCA. BCA is the same as ECD. Again, that's true again. Because of vertex C here and here. AB is the same as CD. Well, that was screwed up. We did not have that order correctly. So AB is definitely not the same as CD. And how about BE? Oh, right here, the same as AD. Oh, no, no, no. Those are actually a totally different set of markings. Those match and those match, but they're different than each other. So that is not necessarily true. So I'm going to have to count that as false because there's no way for me to say that they were actually the same. Okay, like I said, we're going to have to work on our numbers here a little bit because I guess we left off on number 17, but the problems I think are going to be pretty much the same. So moving on, this says BC bisects AD. This is one of those things I warned you about a second ago. It says BC right here bisected AD. So those are the same. But it also told me these guys are parallel. Now notice that I'm taking the information and I'm putting it on the diagram. Now we have a couple of things that we could say, and one of those things that I could do is I could use alternate interiors because these lines are parallel, and I also could add a little bit of vertical angles. So what I have now is an ASA. So are they congruent? Oh, yes, they are. They are congruent. And by what theorem? That's okay. It's funny. ASA. But I could say then that triangle BAE is congruent. BAE would be CDE. And that should do her. Now, a little bit further, similar thing, we've got another crisscross here, so we're going to be able to indicate that these two are the same, and so are they congruent? Yes, they are. And I could say triangle ABC. I'm just going to go ahead and go alphabetical this time. ABC. So notice I started with here and I went across that line. So ABC would be DEC. And that is true. Notice that this time I have two angles, but the side is not in the middle, it's off to the side. So that's an AAS congruence. So remember, I said just always write down the one that you know the most of, and then decide if the angle is here or is it here. And in this case, it's off to the edge. Okay, next one on this one is the shared side. Please do not neglect the shared side every single time. So if this is the same as itself, I've got three sides on the top, three sides on the bottom, absolutely congruent. So I could say that triangle J to K to M is the same as triangle. See, if I said J to K to M, J to K to M would be LMK. By side, side, side congruence. Last one, letter D, last one for this page. Now, this is one of those problems that when we first looked at it, we're like looking for a good example of one that actually failed, and we grabbed it and then went, hold on a second, that's actually true. Notice the 50 and the 70, these don't match. The 70s match, but the 60 and the 50 don't match. And so it's like it's tempting just to jump over here and say no, but we also know that triangles always add up to 180 degrees, don't we? So if I have 70 plus 60 plus some angle right here has to be 180, I know that 130 plus x is 180, which means this x has to be 50 to make that true. So all of a sudden I have these angles match, I've got these angles match, and I got a side in the middle. That's looking like an ASA congruence. So I was kind of fooled by that into thinking maybe they weren't, but in fact they are congruent. And so I could again say that, say maybe triangle BCA. So I'm going to start at the 50 to the 70, and I guess we might as well write a 60 there because we knew that. 50, 70, 60, 50, 70, so EFD. Hey, hopefully that helps. That was the end of that page. I will see you back in class or for the next video. Bye-bye.